What's good, guys? Here we're going to be talking about soil corrosion. We're going to be talking about buried pipes, soil chemistry, and differential aeration. So let's get into it. So soil corrosion is like a slow motion battery where the ground is trying to eat the metal buried pipe. Okay, so that's because there's different types of soil composition. There's wet clay, there's dry sand, and each hold different amounts of water and oxygen. So you can imagine that the wet clay holds lots of water, but not that much oxygen. While dry sand is dry, so it's not much water, but maybe more oxygen. Um, by this imbalance, some parts feel like it's getting choked, while other parts can breathe. So this is called differential aeration, which creates an electrical charge that pulls tiny bits of metals off the pipe into the soil. It dissolves into the soil, and um, when the metals get pulled off the pipe, that causes rust and corrosion and holes in our pipeline, which isn't good. So to stop this, we can coat it in an epoxy, kind of like a rain jacket, and we can add a sacrificial block so that soil can eat that instead of our pipeline. So first question is, how does soil become electrolyte? So soil it's a really complex mix of minerals, air pockets, and water, and this becomes the electrolyte. So electrolyte is like the circuit. How can an electron move on the pipe surface? So because soil contains moisture and dissolved salts like chlorides or sulfates, it has ions in it. So let's give an example like dry sand. Dry sand is a really poor conductor, but when it gets wet and when the water dissolves the salts in the soil, it causes free moving ions, and these free moving ions can flow between different points on the pipe surface, kind of like a fluid in the car battery. So because it gets wet, there's like salts and salts have ions, right? Salt is Na plus Cl minus, and these plus and minus charges can let the electrons move around on the pipe surface. So that's the first one. Second thing is oxygen levels. Wet clay versus dry sand. So I said wet clay doesn't have that much oxygen, but it's really wet. This is because it's like really tiny, it has really tiny, tight packed particles that hold onto the water. So the water fills up the air gaps. You know how in the ground there's air gaps? The water fills up those parts of the ground so that it like physically blocks the pipeline from interacting with oxygen from above the ground. Sandy soil is really loose, so it has large pores and air pockets that allows it to circulate, right? Allows that ground to circulate and allows the pipeline kind of to interact with the oxygen from above. Last but not least, how does this kind of work like scientifically? So think of the sand side is the oxygen rich side, the clay side is the oxygen deficient side. So the side of the pipe in the dry sand has plenty of oxygen. The oxygen is really hungry for electrons, right? O wants O2 minus. It starts pulling it towards, so the oxygen starts pulling electrons towards the metal, and that's the electron flow. So because metal controls electricity, the electrons zoom from the pipe. It zooms from the pipe from the clay side where it has low oxygen to the sandy side that has high oxygen. Because the metal atoms in the wet clay just lost their electrons, without these electrons, the metal atoms can't stay solid anymore. They turn into liquid ions and they literally fall off the pipe and dissolve into the wet mud. So that's pretty much it for soil corrosion. I'll see you guys in the next one.